All right, 3.1, guys. I'm gonna go ahead and give you guys about 3 minutes to write these definitions down. All right. All right, so let's take a quick look at this note, the first slide, class. So remember, a tip, if you're a slow writer and you're still writing and you need more time to write things down, screenshot the slide or take a picture with your cell phone or yeah, so just keep that in mind. So today we're learning about simplifying algebraic expressions. So recall, so when you see the word recall, it wants you to pull back a recent information that we've discussed in this class or you possibly seen in another class. So algebraic expressions is a combination of numbers, letters, which is variables, and operating symbols. So operating symbols are pretty much like mathematics, plus, minus, square, stuff like that. No, when you hear the word no, it's kind of like me telling you a special fact to remember. So note the terms of an expression, right? What is a term? Well, a term of an expression is separated by a plus sign or a minus sign. It's very important that you guys can tell me, you can look at an expression and tell me, hey, Pacheco, that's 3 terms. That's 2 terms. That's 4 terms. It is a skill to know that. Now, what are the different terms? Well, the first type of term is a constant term. A constant term is just a number. It's a constant. So if you see a number by itself, that's a constant term. A variable term is pretty much, there's a term that has a variable. And a variable is typically a letter. Now, the numerical coefficient, guys, the third definition, is the number factor of a variable term. So you're probably wondering, well, what's the number factor, sir? Well, a number factor is just like this. So for example, 7x. This is a variable term, right? The coefficient, the numerical coefficient is the 7. So remember what I said in another class, when we have a number next to a variable, they're being what secretly? Multiplied. And
One.
when they're both being multiplied, guys, there's a number factor and a variable factor. So factors are things that are being multiplied. Any questions on this slide at all? The number of factors. So a factor is things that are being multiplied. That's what a factor is, okay? Next slide, examples of terms, guys. I'm gonna give you 1 minute to copy these down. For x plus 3 class, x plus 3, how many terms do y'all think there are in x plus 3?
3?
So I heard 3 terms. Does anyone agree or disagree with 3 terms?
2.
Jose, what was that?
2.
2. So that causes for a debate, guys. Now, and for you to justify your answer, you need to remember what is a term, right? A term is what, guys? They're separated by plus
Separated by
signs
a plus
or
and a
minus
minus.
signs. So there's one plus sign. So then let's look at the term. So this is a term and that's a term. How many terms is it? 2 or 3?
2. And it makes sense why.
All right, good. Now, what about the third expression? 3y squared minus 6y plus 4. How many terms do y'all guys think there are for the second expression?
I have to say 3.
I'm hearing 3. Does anyone agree or disagree with the 3? Can someone tell me what's what? Name a term from this expression. Name a term.
There's y
Y. So this y is in the term by itself.
as well as y squared.
Y squared is a term.
Oh, shit. I take that back. It's actually just 2.
Okay, so so Justin's changing it back to 2, guys. What are your thoughts, class? Is it 3 or 2?
What about the 4?
The
Oh.
4.
And what about the 3? Oh no. Yeah, it's just
So would we say that, do we separate the letters from the numbers or do we keep it together as one term? Just remember, what separates a term, guys? What operations tends to be between terms?
X and y.
Not X and Y,
plus
not
and minus.
plus or minus. So there's a plus and minus here. So there's actually a total of 3 terms, class, 3 terms. Does everyone understand how there's 2 and 3? Any questions?
So at the end number is a term, a term.
Yeah, what
sorry.
kind of term do we call 4, class? What kind of term is it? There's 2 different types of terms.
Is it the numerical coefficient?
Read the definition of that. Is it, remember, the numerical coefficient is a part of which term?
Yeah. The variable term.
So can someone say, so is there a variable with 4?
No,
It's a constant.
It's
a
a
constant.
constant term. So, all right, let's keep moving. So there will be expressions where terms, they have like terms, right? Like terms is they have the same variable factors with different coefficients. So I'm gonna go ahead and give you guys 2 minutes to write this slide down. Let me make this little chart bigger so I can see it.
All right. Ow. Oh, shit.
All right. Would anyone like more time to write this slide down, guys? Anyone need more time?
All good myself.
Just a tad bit.
Oh, 1 minute?
Yeah, that's fine.
Okay. So while the extra minute's going, guys, I'm gonna give y'all a random pop quiz question. Would y'all say these are the same terms? 7yx and 10xy. Would y'all say they're like terms? Yes or no?
I'm kind of inclined to say yes, only because they're the same, but it's hard to say if I'm right, only because they're flipped around on 10xy.
Okay, so you're a potentially yes, but not a confident yes, right, Justin?
Yes, sir.
Okay, anyone else want to chime in? Do y'all think 7yx and 10xy, are they like terms? Let me give y'all one example real quick here. 2 times 3 is 6, and 3 times 2 is also 6. So what this little example, does that tell us anything about the order of multiplication? Does it matter how which
No.
way you multiply?
No,
So
it doesn't.
knowing this fact, what do y'all think about the original question? Are they like terms? Yes or no?
I'd have to say yes.
Excellent. Good, good,
All
good.
right.
Let me do one more before we move on, right? Because I want to just make sure you guys are understanding this. Can we say 4y cubed is the same thing as 3y? Are these like terms?
No, because you have an exponent on 4y cubed.
Excellent, Justin. That's the biggest difference. Good, good. So does everyone feel a little comfortable what like terms are?
Yes,
All
but
right.
as I always say, just got to keep doing the repetition.
All right, well, let's see how good you really do know. Let's look at, now, before we get into the examples, we're gonna go ahead and write this distributive property down. It says that if A, B, C are numbers, then AC plus BC is A plus B parentheses C. Well, now, when we distribute, the letter could be, the number could be after the parentheses, or it can be in front of the parentheses. Because remember, we established last slide that the order of multiplication does not what? Does not matter.
Doesn't matter.
So I'm going to give you guys 2 minutes on this property slide. Now, whenever I give you a property, it is very, very important that you write it down to its entirety. So you can be like, well, I did that and that because I used the distributive property. I multiplied it out. I did that and got this. Like, properties justify the reasoning behind the world of mathematics. Okay, class?
Oh, wait, am I on mute? Yeah, yeah. I have a question actually now.
Yes, sir.
So basically, they're the same when you had it written down the other way, just flipped around.
Yes, you're talking about this part right here?
Yes, sir.
Yes, yes, that is correct. That is one way.
Alright.
Well, that's one way you'll see distribution, one way, but I'm showing you the other way as well.
All right, no worries.
Just because this is a college course, I am going to try to expose you guys to as many different topics as I can within class.
Hey,
What's up, Jake?
sorry I came into class late. I just don't feel good.
Oh,
So I
Jacob,
overslept.
no, you're good, sir. If you still feel unwell, I am recording this lecture, sir, and I will be posting on YouTube after class is over. And I'll be emailing the link on Canvas. So if you want to log off, sir, and get some rest and do the lecture throughout this week or tonight or tomorrow or on your own time, and you'll text me or email me pictures of the completed notes, you could I'll remove your absence.
Okay. I also did the homework on that peel reel thing.
Oh, okay, you did the my math lab. You got access to that, sir?
Yes.
Excellent, Jacob. Excellent. That's good because you're not on my list. So yeah, that's good. So keep working through those lessons, but also to get your attendance back, your absence removed, just do the lecture notes when I send you the video, or you can get in contact with our embedded tutor, Savannah Padron. She also does the notes too. So you can either watch the video and hear me teach it, or you can get together with Savannah email wise, and she can help you get access to those notes.
Okay.
So
All right.
up to you, sir. If you want to try to do the notes with us, so you don't have to worry about it, you could, but you don't sound too well. So up to you, sir. I'll give you the choice.
Okay. I'll do it on my own.
All right, Jacob. Hey, man, feel better, man. Drink and stay hydrated. Not sure what you're feeling, but stay hydrated, take medicine, and get plenty of rest. All right. Text me, email
Okay.
me if you need anything. Okay.
All right. Thank you.
Mm-hmm.
All right. Bye.
Bye. All right, that was a timer for this slide, guys. Would anyone like additional time to write this property down?
All good on my end.
Last call, anyone? You can always put in the chat or if I'm going too fast, message me, sir, can you slow down? Sir, can I have more time on this? Is everyone good? All right. Example 1, I'm gonna go ahead and give you 1 minute to set up the instructions. And this has 3 different examples, A, B, and C. Example 1 says, simplify each expression. By now, we're combining like terms. I want everyone to know combining like terms is the same thing as CLT, okay? They're the same thing. All right, that's a 1 minute timer. So let's look at A, guys. A is 4x plus 6x. These are like terms because they both have the x term, no exponents. So we're gonna add 4x. So when you think of like terms, I like to think of fruit. 4x plus 6x is 10x. Because 4 plus 6 is 10. Look at B, y minus 5y. Can someone please share what number is invisible in front of the first y that we do not see?
1, if I'm not
One.
mistaken, right?
1, that's correct. And class, if you had $1 in your account and you spent 5 because it's minus 5, what much do you owe the bank?
You'd be
Or-
in the negatives, right?
-4, thank you. And it'll be y. And we're done here. So let's look at C. 3x squared plus 5x squared minus 2. Look carefully at what are like terms. I see that 3x squared and 5x squared are like terms because they both have x squares. So 3 plus 5 is 8x squared. Bring down the minus 2 and we're done because we can't combine anything else. What questions do we have on example 1? Anyone have any question on the steps that we took?
None from myself.
All right, I'm gonna go ahead and give you guys 2
I
minutes.
do have a question for C, if that's all right.
Go ahead, what's your question?
So what you're basically saying with that is it's not necessarily gonna be like 3x², and 5x², but like whatever the number is, and let's say you have a minus, like right here, -2. You'd always bring down the 2 and then stop there, basically?
Yes, because remember that the example wants us to combine like terms, right, Justin? Now
Alright,
look at the 2 and the 8x². Are those like terms?
they are definitely not.
No, this is like apples and oranges, so they're different.
Yep.
So that's why we cannot get this because they're not the same term, okay?
Alright, thank you, sir.
No, thank you for your question. All right, class, so y'all guys have, I'm gonna give you 2 minutes for these 3 practice problems. Good luck. Remember to put your answers online if you can on the chat, or unmute yourself and tell me what you got for each letter, and then I'll write what y'all put. 30 seconds left. Anyone want to share their answers so far for one of them, for A, for B?
So far, I just got A and B, and for A, I got -6M, and B, I got 7A.
Does anyone agree or disagree with Justin's A and B?
I agree. And for C, I got 12y² plus 7.
2y² plus 7, is that what you said?
Yes.
Okay, thank you. So we got some confirmation here and here. Anyone want to confirm Jose's answer for C?
I confirm it.
Excellent. Thank you. Thank you for that confirmation. All right. Any questions on any of these practice problems, class?
For
Any
C, oh,
Uh-huh.
sorry.
Go ahead.
So for C, you're plugging in the 1 then, since it's imaginary, right?
It's what kind of one is it gonna be, Justin?
Just 1y, or -1y, excuse me.
-1y². There you go. So -1, do we owe one or have one, Justin?
You'll, say that again?
Do we have one or do we owe one?
You owe 1.
And how
So
much?
That's how
do
you
we-
got 2.
There you go, because we owed 1 and we have 3. Yeah, there you go. And then you
Right.
bring down the 7 because they're not what, sir?
They're not like terms.
Excellent choice of words. All right, let's move on. All right, now these properties, guys, is kind of what justifies some of the steps that we do in math. I'm gonna give you 4 minutes on this slide. It is gonna be a little bit tedious of writing, but remember what I said, these properties are meant to help you understand the reasoning behind some of these things, the reasoning why we can manipulate equations, the reason why we can add the way we add, the reason why PEMDAS works, because of properties like this. And the helpful hint in the bottom is physical numbers. An example, like they plug in numbers instead of the letters A, B, and C. And the key to this, the reason why I'm having you guys, I'm having you guys do this is because of this. That is, the order of adding or multiplying can be changed without changing their sum or product. And also grouping numbers and adding and subtracting will not change it either. That's the main thing that I want you to take away from this. Now, while you guys are writing this, let's see if, so this is commutative, right? Commutative property of adding and multiplying. Let's see if subtracting is commutative. Is 7 minus 3 the same thing as 3 minus 7, class?
No.
No, there isn't. So they're not commutative. So the only ones that, the only operations that have commutative and associative is addition and multiplication. All right, class? So that's why the order of subtracting and dividing matters, whereas the order of adding and adding and multiplication does not. Does everyone see the difference?
Yeah, because whenever you brought up 7 minus 3 and 3 minus 7, you get a negative number for 3 minus 7.
So therefore, the order of subtracting does matter, sir.
Exactly.
Good. All right. Would anyone like additional time to copy this slide down? Anyone?
I would.
Oh yeah. Would you like 1 minute, 2 minutes, or 3 minutes?
Let's go with 3.
3? Okay.
Yeah.
Let me know if you finish before the 3 minutes, okay?
Okay, thank you.
Mhm. Did everyone have a good weekend?
I went gambling at Kickapoo and won a bit of money, so I definitely can't complain.
Nice. Do you slot or cards? What are you playing?
I was doing the slots down there.
Oh, nice. I have no luck with slots.
After being there and seeing how much you win at a time, I don't blame you for saying that.
Me and one of my best friends went to because I went to college in North Texas, so we're not too far from Windstar.
Yeah, I used to live in Fort Worth, and that's where I grew up, and I went there on my 18th birthday.
Oh, nice. That's really nice. Yeah.
Yeah.
We both put in $20 in the same machine, like next to each other. I lost $20. He won $300.
That's amazing.
Yeah, I was like, this is not right.
When I was at Kickapoo, there was an older lady too when I was about to leave and drive back who was playing her husband's game and she won a $1,200 jackpot.
Nice, nice.
I know.
I like poker. I like to play Texas Hold'em. I'm a card guy.
Can't blame you there.
It was kind of when I was a high school teacher, a lot of my high school students that were seniors were like, sir, when we graduate, they were part of my mathletes. And they were like, sir, we had watched the movie 21, like the gambling movie where they learn how to count cards. They're
Oh,
like, sir, we
yeah.
should do this, but don't be like the professor. I was like, if y'all seen the movie, the professor's like evil, like the bad guy.
Oh, that's
Is it
funny.
the one with the chicken winner dinner?
Possibly. It's been a while since I've seen the movie, but yeah, chicken.
It's funny too, because I've actually I've been to Vegas too and gambled there.
No, I
Okay.
haven't. You good? Okay,
Yeah.
cool, cool, cool. Also, and that was within the 3 minutes. Awesome. All right, guys, I'm moving on. All right, example 2, guys. Example 2. So now now that we're learning more concepts about algebra and mathematics, our examples are gonna get a little more difficult, but please stay focused. So example 2, I'm gonna go ahead and give you guys a minute to set it up and then we'll get started. So we want to simplify 2y minus 6 plus 4y plus 8. As you guys are writing this down, I want you to start thinking, okay, well, what are like terms that we will be able to combine? If anyone wants to share and they're confident, be like, oh, I think it's going to be these. Please unmute yourself and tell me what,
And I already see. Oh, sorry.
go ahead. Which would
I
you
see
like?
an
See
example
two.
too.
The 2?
Yeah,
Okay.
2 and the 4y,
The 2
or
and the
2y
4y.
and
And then
4y.
6 and 8.
6 and 8. Good, 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 good. Now, if you don't have highlighters to do color coordinating like I'm doing, you can underline it. So 1 underline for the y's and then 2 underlines for the numbers, the constant terms. And then combine them, guys. When we combine the y's, 2y plus 4y is just what? 6y. Negative 6 plus 8, I owe the bank 6, gave them $8. So now I have 2 to my name. And that is it. Anyone have any questions on how I combine like terms in example 2?
Well, the question I have is, because of course this will come up in my math lab, and I've made this mistake before. If it says simplify, you're getting something like 6y plus 2, and you're not solving it unless it says solve, right?
Exactly.
Okay, okay.
Now, question, Justin, is this an expression or an equation?
It's an expression.
Why not an equation?
Oh, wait, no. It's actually an equation because you have it written 6y plus 2, y is a factor. Sorry about my dog.
No, you're good. Anyone want to
And
chime in on Justin's thought? He's saying this is an equation. Anyone agree with that? That this is an equation, not an expression? Anyone want to chime in? Is it an expression or an equation, class? That's the question about this example. Or does no one know? Does no one feel comfortable?
the suspense.
The suspense is killing
I
me.
want to say an expression because an equation you have to equal to something.
Yeah, actually, that is
There you
true.
go, there you go. So you're correct. This is an expression. Because there's no equal sign. All right, practice 2, guys. 1 minute for practice 2. Good luck.
Well, on practice 2, I got 5z minus 1.
5z, you got 5z minus 1?
Yes, sir.
All right, anyone want to chime in with that?
I got 7z plus 1.
7z plus 1.
Ah, can someone share with what mistakes they Justin possibly could have made?
I actually
Subtracting the
changed
6.
Subtracting the 6 from the 1. And you put the negative with the 5. So remember, 6z plus 1z is 7. And then we have to do 5 minus 4, right? Which gives
Yeah, I
you.
misread it.
Oh, you're good, sir. So you're good?
Yeah.
Okay, cool. All right, let's move on. Here is 3 examples, guys, 3, 4, and 5. I'm going to go ahead and give you a minute to set up the first one, 3. So this is 3 different examples here. So we have example 3, example 4, and example 5. For example 3, guys, are there any like terms that we can simplify?
6y and 12y because they're like terms.
And when you combine them, you add them, what do we get?
You get 18y.
Can we combine it with minus 6?
You can, you get 18y minus 6.
Okay. Let's move on. 4. 4x plus 2 minus 5x plus 3. Any like terms, class?
4x and 5x.
And then any other ones?
2 and 3.
Let's combine them. 4x minus 5x. You have 4 but spend 5, so you still owe 1. And then 2 plus 3 is plus 5. Example 5. What can I combine 2x with?
You can connect it with 4x.
4x.
Can I combine negative 5 with something?
You can combine it with positive 11,
Can I combine 3y with something?
with 10y.
Negative 10y.
Excellent.
Negative 10y.
I've combined it. So 2x plus 4x is 6x. 3y minus 10y is negative 7y. Negative 5 plus 11 is plus 6. And we're done. Any questions on how we combine like terms with these expressions?
On 4, I got kind of thrown off on it for a minute because, you have the like terms next to each other. And I was thinking you had to add, but of course we ended up subtracting. So typically whatever symbol is in front of it, plus or minus, is what you do if it's a like term.
That is correct, sir.
Okay, thank you.
All right. All right, let's move on. Here is your 3 practice problems, guys. I'm gonna give you all 3 minutes. I'll start with 2 minutes because they're pretty simple, but if y'all need more than 2 minutes, I'll add more time. Good luck.
And I said, what? Why is anybody interested in me welcoming my social media?
All right, guys. All right. What'd y'all get for these practice problems? What'd y'all get for number 3?
I didn't finish 5, but I got for 3 and 4, I got 18y minus 6. And for 4, I got 8y plus 13.
AY plus 13.
Yes, sir.
Okay.
I
Yeah,
agree
well-
with number 3, but not with 4. I got AY minus 3. number four.
For number 4.
Yes.
Okay. Or 8y minus 3.
I agree. 8y minus 3.
And for number 5, I got negative 9y minus 10x plus 14.
Negative 10x plus 14.
Yes.
Okay. So we had someone confirm this one over this one. And anyone want to confirm 3 or 5?
I confirm 3.
Okay, good, good, good. Now, I hate to be the bearer of bad news, guys, but these are both wrong for number 4. Let's see what we can find out our mistakes. So let's look at the like terms. What can we combine in number 4?
Well, whenever I was doing it, I combined 7y and 1y,
Which gives us,
8y,
and then we can combine what?
negative 5 plus. Oh, I see the problem then. I didn't realize this is a negative.
Mhm.
Oh, plus 3. It's plus 3.
Plus 3, excellent.
Yeah.
Y'all see that? Yeah. So it's 8y plus 3. So make that changes in y'all's notebook class. Now for number 5, anyone have any questions about it? So I'll tell you right now, it is correct. Number 5 is correct. Does anyone have any questions on how we got it?
Is it because you combine negative 7y and 2y, then you combined 2 and 12, because of course they're like terms, then simultaneously combining negative 9x with 1x,
What kind of 1x?
negative 1x.
There you go. All right, yeah, and that gives us a negative 10 and so forth.
That makes sense.
All right, let's go ahead and move on. All right, here's another example, 6 and 7. I'm gonna go ahead and give you about 1 minute to write this down. Class, remember what I said about when we have a number next to parentheses? What operation is happening?
Multiplication.
Multiplication.
Good, 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 good. So when we multiply a number with the variable term, all we do is pretty much multiply the numbers, right? And the variable stays the same unless there's another variable involved, right? So what's 5 times 3y?
15y?
15y, that's correct. What's 7? Example 7 is negative 2 times a 4x. What's a negative times a positive?
Negative 8x.
Negative 8x.
And we're done. Does anyone need more time on this slide? Like an extra minute or so? Speak now or forever hold your truth. Okay. I'm gonna go ahead and, we have some example 8, 9, and 10. Give you 1 minute to set up example 8. Now, a little tip before we get started, guys. Distribution last semester was juicy because last semester a lot of my students could not process what distribution is. So if you remember this from high school and you're good, perfect. If you're one of those that math is in your strong suit, it's been a while, it's been a minute, and after these examples, you're not comfortable with it yet, and the practice still not enough, I highly recommend meeting up with our embedded tutor or going to the math lab for extra explanation, okay? YouTube does have videos on distributive property too, so you can utilize technology as well. Just take advantage of doing whatever you can to understand this topic. Because I'm giving you a heads up because you will see this a lot. And if you don't distribute correctly, you will make mistakes. So we know that distribution from the property that you wrote in your notebook, that when you have a number C times A plus B, we multiply the C to the A and then the C to the B. We're gonna multiply this to each other. So then we're gonna get 5 times X plus 5 times 4. That's what distributive means. We're gonna distribute this 5 to the things inside and then multiply. Well, 5 times X, that's just 5X. 5 times 4, that's just 20. And we're done. Because we cannot simplify or combine the like terms. So now let's take a look at example 9. We're gonna multiply -3 parentheses 5a plus 2. This is still distributive property. It's still distribution. So I'm gonna go ahead and draw arrows from the -3 to the 5a and -3 to the 2. I personally use arrows to denote distribution. So I know that my -3 is gonna be multiplied to 5a. And then I'm gonna do plus -3 times 2. I'm only putting a negative here because I don't want you parentheses around here on the second one because I don't want you to confuse the plus minus. I need you to know that the 3 is negative. So then we multiply, class. -3 times 5a, that's -15a. -3 times 2, that's -6. But we have a plus of negative. Remember what I said in class earlier, that if we're ever adding a negative,
Cancels out.
as the same thing as what operation? We're technically still just what? Are we subtracting or adding?
Doesn't it cancel out to a
Subtracting.
positive?
It doesn't cancel out, Justin, but there's
Oh,
no such thing as adding a negative. If you're adding a negative
course.
number, you're only, because I say I tell you, hey Justin, I want you to clean my yard. I'm gonna give you -$10 from that. Well, if you're
Yeah.
doing if you're adding -$10 to your account as your
You're
money
going
goes
down
down,
negative.
you're gonna go down, right? And what operation is going down?
Negative.
So yeah, negative, so it's subtracting.
That makes sense.
All right. Now for the last one, we're gonna distribute 8 to X and 8 to -4. So we'll get 8 times X minus 4 times 8. Well, 8 times X is 8X. -4 times 8 is -32. And we're done. Are there any questions, guys? Any questions on how to distribute, how to simplify?
So on example 9, then you'd, of course, like the other ones, bring down 3 and 5, and you'd multiply it to 15. So would it always be adding the parentheses like how you have it -3 and 2?
So
If
I
it's like
only
this?
added these parentheses so I don't get confused
Okay.
with this symbol here.
Okay.
Cause remember, as long as you remember, and then over here on the -4, I wanted to remember, it's -4, so that's why I kept this minus.
That makes sense.
And I put the 8 second, because remember what I did earlier, that the order of multiplication does not what?
Matter.
These are equal, right? Yeah, with me?
Yep.
All right. Let's move on. Here's the 3 practice problem. I'm gonna go ahead and give you 4 minutes on these bad boys. Good luck. I'm gonna go get a water, guys. I'll be back. All right, guys, I'm back. Let me see how much is on the timer. Yeah, okay, we're about 5 seconds left. All right, does anyone have any questions? Anyone want to show what they got for practice 8?
Probably close.
8y plus 16.
8y
Yeah.
plus 16. Okay, good. Anyone agree or disagree with 8y plus 16?
I agree.
Good,
Agree.
that's correct. What did y'all get for practice? 9
21, 8 minus 15.
minus 15. Anyone agree or disagree?
Agree.
Agree.
That is correct. What about example 10 or practice 10?
30 minus 6y.
Anyone agree or disagree with this?
Agree.
And you are correct. Good job, class. Anyone have any questions, comments, or concerns on these practice set?
Would it be possible if you could explain them a little bit?
Yeah, which ones would you want me to explain, sir?
I think 9, because I was close on 9. I got 21A, but I ended up with 5, which of course is incorrect. So
Ah, Justin, did you draw your arrows of what you're multiplying?
yeah, that's what I forgot.
Well, you have to do 3 times the 7a, which gives you the 21a, but we also
Right.
have to do 3 times 1.
Oh, yeah. That makes more sense because I only did the first step, but forgot the second one.
And the way you can forget that is by just drawing your what, sir?
Arrows,
There you
exactly.
go. I know a lot. I remember one student last semester, she gave me a little attitude. Well, I don't need to do the arrows, sir. I'm fine. And then what happened on one
Yeah,
of the
you need
tests?
them.
Yeah, she didn't distribute to the second term and she was triggered. She's like, well, can I
It's
get my
sort of
credit?
like, oh,
Can I
sorry.
get credit back? And I told her, no, there's no credit because you didn't do the correct work. So you just make sure the techniques I'm showing you here are techniques that I picked up that allowed me to be successful in my math classes. Now, they may not work for you or they may work for you, but it's up to you to try them, okay? Go ahead,
It's
Justin.
it's sort of like what I mentioned last week or the week before when I said, does it help writing PEMDAS? Sort of the same thing here with the arrows.
Exactly, sir. All right, now we have some more expressions, but now they're getting more complex. Now we're distributing and we still have to combine. So I'm gonna go ahead and give you guys a minute. All right, you have 1 minute. And I'll get started on example 11. There's 3 parts to 11, guys. There's A, B, and C. So quick question, class. As you're writing example 11A, the 2 parentheses 3 plus 7x minus 15, can we combine like terms before we distribute, or do we need to distribute first and then combine? What's your mind telling you? What do you think?
My
Distribute,
gut-
then combine.
There you
yeah,
go.
that's what I was gonna say.
Excellent. Distribute and then combine. That is correct. We're gonna go ahead and distribute the 2. So I'm gonna get started. So 2 is gonna be distributed to the 3 and to the 7x. Now, is my 2 gonna be distributed to my 15? Yes or no? Why or why not?
I got stuck on it, but I think I understand now. I want to say yes because neither of them have an X behind it or a Y, so they're like terms.
No, well, my question
Say
was
no,
no. So why wouldn't we, Jose?
because they're
Outside the
different terms.
parentheses.
Yeah.
Yeah, see that? The parentheses? Distribution only works with what's in the parentheses and not out. Does that make
Okay.
sense, class?
Yeah.
So now
Whether
I'm
you're
gonna
in or out.
so we're only gonna distribute it to the in, not the out. So then 2 times 3 is 6. I'm gonna skip the step that has the 2 times 3. If you don't want to skip that step, you don't have to, but for the sake of space, I'm gonna skip that step. 2 times 7x is a positive 14x. Bring down the minus 15. And from here, what can we combine, class? Any like terms?
15 and 6. Negative 15 and 6.
And negative
Yeah.
18, yeah. So then we get 14x minus 9. And we're done.
That's crazy because I actually got the first part, 6 plus 14x minus 15, but then forgot this part, but okay.
Remember,
Now I
so
get what you're trying to
so
say.
next to this step, I want you to write CLT. Does everyone remember
CLT.
what CLT stands for?
Combine like terms.
There you go. Let's go to example B, class. How many times do y'all think, or do y'all see we're gonna be distributing in example B?
Two
Twice.
times.
Twice, right? The -2 here, and then the 4 here. So let's do it. -2 times x is just -2x. -2 times -5, two negatives make a positive. 2 times 5 is 10. 4 times 2x is 8x. 4 times 2 is 8. Now, what like terms do y'all see here, class?
X and the regular constant.
That's correct. So -2x plus 8x is 6x. 10 plus 8 is 18. And we're done. Now let's go to the last one. What number is right here next to this minus sign that we do not see? It's
1.
invisible.
1,
What kind of one, class?
Negative.
negative.
Excellent. Draw your arrows. -1 times x is -x. -1 times 4 is -4. Bring down the 5x plus 16. Combine the x's and then the constant terms. -x plus 5x is 4x. -4 plus 16 is 12. And we are done. Any questions on the examples we just did right now? On the distribution, and then I'm gonna write the step CLT next to this line. After you distribute, we have to combine like terms. Do not forget that step.
So you could apply PEMDAS in this too, since kind of a little bit, if that makes sense.
Well, actually, to simplify, you do use PEMDAS. That is correct, Justin.
All right.
That's why, remember, in PEMDAS, what do we do first before we add and subtract? What do we do first before we add and
The
subtract?
parentheses and distribution.
Which is, distribution is what operation? Multiply. We have to multiply before we what?
Add and subtract.
That's why we distribute first and then add and subtract.
What if we have an exponent like after the parentheses?
Like right here, like that.
Yeah.
If we have an exponent like that, we have to do the exponent first. We would have to do 2x plus 2 squared first, and then distribute the 4 to that answer. But we'll get to that.
Okay.
We will have examples like that later on. So let's, but that's a great question though, by the way. I really do like that question.
I have a question.
Yeah, go ahead, Sophia.
So do like in these problems, do like the signs matter? Like if you have like a plus and a plus equals like a positive and a negative equals a negative, does that come in handy with
Yeah, so
this?
so you're talking about the little box I did for you, like a positive times
Yes.
a positive equals a positive. Yes, you want to remember these rules, Sophia. Let me tell you why. Because when you distribute, we're right here, look at the B, -2. Right here, we're multiplying a negative times what kind of X?
A positive?
So we would know, so a positive, a negative times a positive is what?
A negative?
But we would know this is -2x. Does that make sense?
Yes.
So that, yeah, this is where that will come into play, man. When we're
Okay.
distributing, because if we didn't know that, right? What if we made it a positive by accident because we didn't remember that? So this is where that will come into play, man, when distribution, okay?
All right, thank you.
That was a great question too. Nice. All right. Any other questions, guys, before y'all do your practice problems? Any questions? All right, good luck. I'm gonna go ahead and give you all 5 minutes on these because these are juicy. Give you 5 minutes. A, B, and C. And if anyone wants to share what they got for A, B, and C, just unmute yourself or put it in the chat.
I got 10y minus 23 for A.
10y minus 23 for A. Anyone confirm that or disagree with that?
I agree.
What about B?
I got 3x plus 22.
Plus 22 like that?
Yes.
I don't know why I put Y, my bad. Anyone agree or disagree with that? Yeah, timer's not over yet. I was just checking to see if y'all made any progress yet.
I agree.
Excellent, excellent.
For C, I got 2y minus 13.
2y minus 13.
Yes.
Let's see if anyone agrees or disagree. All right, anyone want to confirm what they got for C? Did they get 2y minus 13 or something different?
Can you go over B and C?
B and C, yes, I
I
can.
agree for C.
You agree for C? Okay, cool. Let's see how we do. So I was asked to cover B and C. Anyone need me to cover A before I start B and C?
It wouldn't hurt.
It wouldn't hurt. All right, so we're gonna go ahead and distribute the 5, right? So draw your 2 arrows. We're gonna multiply 5 times 2y is 10y. A positive 5 times a negative 3 is a negative 15. Bring down the negative 8. We can only combine the 15 and the 8, but they're both negative. So we owe the bank 15, but we borrowed 8 more, or we spent 8 more. So we owe the bank 23. So hence 10y minus 23 is correct. Let's look at B class. B wants us to distribute the -7 twice and then the 5 twice. So -7 times x is -7x, right? And then a -7 times a -1 is a +7 because we're multiplying class. 5 times 2x is 10x. 5 times 3 is +15. Well, I'm gonna combine the -7x with the 10x. You owe me 7, but you put in 10. You give me 10. Well, you're gonna have $3 back in change, so we have 3x. And then we combine the 7 with the 15 because they're both constants and they're both positive, so we just add them, giving us 3x plus 22. That's correct. Now let's take a look at C, right? So C is we're distributing what value? What number is being distributed, class?
-1.
A -1, correct. So then we get -y minus 1, bring down 3y minus 12. So now we combine the y's. So -y and 3y, you owe me 1y, right? It's a -1 invisible here, right? So you owe me 1, but here's $3, Pacheco. So then you only have 2y left. And then you owe the bank $1, but you spent 12 more. So in total, you still owe them 13. So C is correct. What questions do we have on any of the steps that we took to solve these practice problems, class? Is there any questions or comments or concerns?
I think I've noticed with these, it's just Got to keep practicing it because I noticed at least for myself, I get the first step, then miss the second and third, if that makes sense.
Then that's okay. All right. So let's go ahead and, I'm gonna go ahead and stop, now, before I stop recording this lesson, because we need to start the next one. Quick question, class. Does anyone have any questions, comments, or concerns regarding 3.1, guys? Any questions at all? Or comments or concerns? Okay, I'm gonna go ahead and stop recording. All right, guys, back to me writing. All right, let's take a look at example 1, class. It's an equation, right? Y minus 5 equals -2 minus 6. Do y'all see any, so the left side, can I combine y minus 5? Are these like?
No,
terms?
you have to switch it out.
So leave it there. What about the -2 minus 6? Can we combine these terms?
You can.
Yeah, what's -2 minus 6? You owe 2 spend
-8.
-8. Now, no more, each side is simplified to the best. So I'm gonna write it down. No, each side is simplified. I'm so sorry that my handwriting is shit, guys. Like, I'm just, let me try that again. There you go, much better. Each side must be simplified. So we did that, right? So now we get y by itself. How do I move a -5 to the other side, class? What is the opposite of -5?
It's 5.
+5. So let's go ahead and +5. What we do to one side, we do to the other. So then we get y equals, you owe me 8, but paid 5, you still owe me $3. So y equals -3. Here, Palmer, well, Pacheco, how do we know if we're right? How can we check it? Well, guess what? You can plug in this number into y and see if it's true. So then we do check. -3 minus 5 equals question mark -2 minus 6. Well, we know the right side's -8, right? Well, on the left side, you owe me 3, borrow 5 more. Now you owe me 8, which is true. So this is correct. So that check still works, even though the equations get harder or trickier, it still works. Now I'm gonna go ahead and give you guys about a 1 minute to go ahead and solve the practice 1 problem. And when you write your solution, make sure you have the x equals a number, like write down the way it is. All right, what'd y'all get for practice 1, guys? What was the solution? Anyone want to share what they got for practice
X
1?
equals to 4.
I got x equals 4. Did someone get something different?
I got x equals -8.
Oh, 2 separate answers. The plot thickens, class. The plot thickens. Oh, and then Justin got x equals -9. So that's also different. So let's talk about it. So what's the first thing we have to do? Is the left side simplified, class? Yes or no? Can I
Yes,
combine x and 6 together? Are they like terms?
it is actually not like terms.
Let's just bring it down. Can I combine the right side?
You can.
What is 1 minus 3?
2.
What kind of 2?
Positive.
So I want you to say 1 minus 3 in terms of money, Justin. So do
Okay, no
we have
worries.
$1 or do we owe $1?
You actually owe, to be fair.
We owe $1? You sure? What kind of one is that?
Positive.
So when it's positive, we owe money or do we have money?
Now you actually have.
And then minus 3, are we spending 3 or adding 3 to our account?
You're spending.
So if you have $1 in your bank and you spend 3 at the store, you're
Go
gonna have, you're gonna have $2 still?
No,
You're gonna what?
have -2.
There you go.
And then
see.
subtract 6.
Subtract 6. What we do to one side, we do to the,
Other side. And then it's -8. My bad.
no, you're good. You owe 2, you spend 6 more, so now you owe $8.
Looks like I did the right steps, except what I did wrong is I subtracted both sides instead of adding them on the one side. Hopefully that makes sense.
No, you're good. As long as you catch your mistake, Justin, that's the key.
Yeah, yeah.
Alright, any questions on practice 1 class? Any questions? Alright, here's example 2. We have 3 different types of equations to do. So we have A, B, and C. I'm gonna give you a 1 minute to copy A down. You can skip a few lines and write B if you want to. Remember the thing I wrote in the first slide. Before we start solving things, we have to make sure both sides are simplified to the entirety. Alright, now this is an example, so I'm gonna work it out. So let's look at example 2A. So draw the line down the equal sign. The 12 is already simplified, so I can't mess with the 12, but I could mess with 3y minus 7y. I have 3, spend 7, so I still owe 4y. Now -4 and y are being multiplied. To move it, I must do the opposite of multiply. Opposite of multiply is divide. What I do to one side, I would do to the other. The reason why I divide by -4 is because I want to cancel both of these numbers out. And if I do 4, the negative will stay there. I need to do -4. So this gives us y by itself. 12 divided by -4 is -3. And we're done. Now let's take a look at B. Draw the line down the equal sign. The left side cannot be simplified anymore because it's just dividing the z in the -4. But here 11 minus 5 is 6. We get to combine those two because they're constants. Now look at the left hand side, guys. What's the opposite of dividing -4?
Multiplying.
Multiply. So I'm gonna multiply -4. And then parentheses -4 here. Cancels out the -4, we get z equals -24. And we're done. Look at C. Draw the line on the equal sign. Can I simplify or combine any like terms on the left side, class?
You can combine 5x and -4x.
It gives you what?
That gives you -20x.
Ah, how'd you get that?
Wait, you're not supposed, oh crap, you can't multiply there.
Oh, yeah, we're not distributing, sir. We're
Yeah.
just, we have 5 apples and we're getting rid of 4 apples. So how many apples do we have left?
You have
1.
We have 5, get rid of 4.
you have 9.
1x.
1x.
1x, yeah.
Because what kind of 4 is it, Justin?
Negative,
And how many, what kind of five is it?
positive. So you're owing
So we have five, but we spend how much?
4.
So we still owe?
No, actually, you're spending.
So, no, it's not about spending. It's about, yeah, we're spending four, right? But how much do we have left after we spend the four?
You have 1.
We have one X, yep. Bring down the +2. Now, what can we combine on the right? Can we combine the right?
You can.
What's 7? We have $7. We spend 19 on the store. How much do we owe?
You owe -12.
Now when you get X by itself. So how do I move a +2 to the other side?
Subtracting 2.
Subtracting 2. So we have X equals, you owe 12, but spend 2 more. So now you owe the bank how much?
-14.
14, and we're done. Are there any questions on what we did on A, B, and C?
So we're not subtracting 12 and 2 because there's two negative signs which equals a positive, so we're adding.
Ah, so that concept, Sophia, that's only for multiplying numbers. Here, we're doing -12 minus 2. This is -12 minus 2. If it was -12 times -2, then it'll be a +24. But here, these two are different. So we're not doing that. So we're doing this. So that's why I kind of bring money to these kind of problems, because we know money, right? So -12 means we owe the bank 12, right? And then minusing 2, that means, are we spending 2 more or are we adding 2 to the account? We're spending, right?
Spending.
So in total, if we owe 12 the bank already and we spend another 2, we owe the bank how much?
14.
Instead of +24, which wouldn't make sense, right? You see that? Do you see the
Yes.
difference from the two different concepts, Sophia?
Yes.
Okay, good. And if you're unsure, like once we move back to campus and you're like stuck on homework or something, you can always ask me or the tutors, okay?
Yes, sir. Thank you.
Yeah, I'm all here about helping you build your confidence up again, you know? That's
Sir, I was getting too into it. I was gonna subtract the 1 from the X.
the one for, oh,
I
but
was getting too into it.
no, you're good, dude. I feel you. That's me every day when I teach. So, but you're good though, right? You're good that we don't touch the one, right? Because it's invisible, kind of, you know? I just didn't write in the answer so I don't get confused and do that again. You know what I mean? So remember, guys, that 1x is the same thing as x, okay? Just like -x is the same thing as what? -1x. Everyone with me on that, guys? How the
Yep.
ones can be invisible? All right.
So if it was a negative, would we have to distribute that? or
We
no?
would have to divide by -1 to get rid of the negative, sir. Yes, correct. Because we only want the letter by itself, no negative number, okay? All right, here's the next set of practice problems, guys. I'm gonna go ahead and give you guys about 4 minutes on these. Remember to use the properties. I'm gonna step away. I drank too much water. Give me a second. I'm back, class. Anyone have any questions so far in any of these practice problems or any answers they want to share with?
So, on A at least, you do the 2m minus 4 first.
What do you get when you do that?
You get -2, and then you subtract -2 from 10.
Are you sure? What's happening with the -2 with the M? When you have a number next to a letter, are they adding, subtracting, multiplying?
Multiplying.
And what's the opposite of multiplying, Justin?
Division.
Dividing
So you divide by what?
10.
Not by 10, you wanna get the M by itself,
2.
so you divide by the -2.
Okay.
Remember, look at your examples, guys. We just covered some examples on these. Look at the steps we did. All right, that was the timer, guys. Would anyone like more time to work on this? Or are y'all ready to go over him? Does anyone need more time or are we ready to go over? Who's still sobbing? All right, what'd you get for A? What'd you get for M equals, Justin, when you divide it by -2?
Say that again?
What did you get for the first one?
Well, whenever you said divide by -2, I got, let me make sure I redo it just to make sure I got it right, which was I got -1.
Okay, so from this line, what did you do next? From 10 equals 2M minus 4M, what did you write next?
I got M minus.
I'll tell you.
I got M equals -5.
-5. How did you?
I agree.
You agree with the -5?
Oh, wait.
Good. Cause when you got
You're
down,
dividing 10 and 2, right?
yes, there you go. Did you hear that, Justin?
Yes, yes.
So to get the M by itself, we have to divide by -2 on both sides. These cancel out and what's by itself now?
EM,
And then we have to do what in the calculator,
you divide 10 and -2,
which would give us what?
-5.
There you go, sir. Okay. All right, what y'all do for B, guys? What y'all get for A equals?
-6. That's what I got.
Anyone want to agree or disagree with Jose Gabriel?
I agree.
You agree. Good, good, good. Anyone want me to run over or go over B?
I do.
Okay, let's go. Let's talk about it. Draw the line down the equal sign, right? Can I combine the left side, guys? Are these like terms?
Yes,
What's -8 plus 6?
-2.
Bring down the A over 3. What's happening with the A and the 3? Is it being added, subtracted, divided, or multiplied?
Divided, but you have to multiply by 3.
We had to multiply to cancel it out. So put the parentheses, right? Because that's another way to multiply. These cancel out. 3 times a -2 is a what kind of 6?
-6.
There we go. Now let's go ahead and look at C, class C. Can I combine any like terms on the left side?
The y's, the
Y's.
-6 and the
What's
plus.
-6y plus 7y?
I
1
got
1y, right? Because you owe me 6, but you have 7. But do I have to write the 1 next to the y?
no.
No, I don't have to, but I could. Bring down the -1 equals, can I combine 17 and 2?
Yes, it's 19.
And now how do I get the y by itself?
You add the +1 on
So
both.
then get y equals what?
20.
There you go.
We're gonna check if they're true.
We could, yeah. Or no, sake of time, we're not. The sake of time, we only have a few minutes left. So, no, but they are right, though. I will tell you this, they are right. Now, if you're doing problems on your own, you're practicing, you check it, you plug it into the original. So then the -5 will go here for M and M. This -6 will go for A, and the 20 will go for the Y's. And then you use PEMDAS to simplify, okay? No, yeah, we'll stop there. We'll stop here, guys. All right. So real quick, class, are there any questions on the lessons that we've done so far, like the examples here? Any questions, comments, or concerns?
Will we have to like